depths where sunlight will never reach, a creature waits. Draped in skin that swallows nearly all light, under pressures no human could survive. Scientists have spent decades searching, yet some species have been seen just 9 times in over 28,000 hours of deep ocean dives. Angelfish break every biological rule you know, from luring prey with living light to males fusing forever with their mates. But what forces could sculpt life this strange, and why are so many secrets still hidden in the dark? More than a kilometer beneath the waves, where pressure crushes unprotected flesh and temperatures rarely rise above 4 degrees Celsius, anglerfish drift in a world stripped of light and warmth. Their bodies are sculpted for survival in these extremes. The skin, so dark it absorbs nearly every photon, acts as a cloak, reflecting less than 0.1% of any stray light. This ultra-black surface is packed with melanosomes, dense pigment granules arranged to trap and scatter what little light exists, rendering the anglerfish almost invisible even in the rare event of bioluminescence from other deep-sea creatures. At these depths, the pressure is relentless, up to 400 times what we experience at sea level. Human-built submersibles require thick metal hulls to withstand it. The anglerfish, by contrast, is soft. Its flesh is gelatinous, bones are reduced, and the body is flexible, allowing the animal to resist crushing forces without expending energy on heavy armor. The tissues are laced with water, matching the pressure outside so precisely that collapse is impossible. Internally, organs are simplified and metabolic rates are slow, conserving precious energy in a place where food is scarce and hunting is a gamble. Sensory systems are tuned for the abyss. Along the head and flanks, pores detect subtle changes in water pressure and faint electrical signals from distant prey. Eyes are large, but in some species, they are reduced to tiny specks, useful only for detecting the faintest glimmer. The real challenge is not seeing, but remaining unseen, lying in wait for the rare moment when a meal drifts close. Dr. Luis Alvarez, who has spent decades studying deep-sea adaptations, describes the anglerfish as a masterpiece of pressure-proof engineering. Every feature, from the loose skin to the enormous mouth, is a direct response to a world where energy cannot be wasted, and mistakes are rarely forgiven. In such an environment, only the most efficient solutions endure. The anglerfish's body is not built for beauty, but for survival in darkness so absolute, it might as well be another planet. A single thread rises from the anglerfish's head, swaying gently in the black water. This is the elytium, a modified dorsal fin spine, and at its tip sits the esca, a living lantern in the void. The glow, a soft blue-green pulse at about 470 nanometers, slices through the darkness farther than any other color could. But the anglerfish herself does not create this light. The esca is home to symbiotic bacteria, most often from the Vibrio family, that have traded independence for a life inside the lure. These bacteria have shed much of their genetic baggage, their genomes stripped down to essentials, perfectly tuned to survive in the nutrient-rich shelter of the esca. Dr. Edith Witter, a pioneer in deep-sea bioluminescence, describes the relationship as a mutual pact. The anglerfish provides the bacteria with food and a safe haven, while the bacteria pay rent in the form of light. This arrangement is not inherited from parent to offspring. Instead, each new generation of anglerfish, as juveniles, must acquire their glowing tenants directly from the ocean itself. Only when the esca forms does it become colonized, as the fish drifts through the same waters where the bacteria persist, ready to move in. The chemistry behind the glow is both elegant and efficient. The bacteria use a luciferase enzyme to trigger a reaction that releases photons, all powered by nutrients from the host. Because the bacteria's genomes have shrunk, they can barely survive outside the esca, making the partnership almost obligatory. The anglerfish, in turn, can control the lure's movements with specialized muscles, twitching and pulsing the light to mimic the flicker of small prey. In a world where every calorie counts, this is not just a beacon, it is a trap. Prey, drawn by the promise of an easy meal, come close enough for the anglerfish's massive jaws to snap shut. The lure's glow is a rare luxury in the deep. where hunting by sight is nearly impossible. Here, the anglerfish turns darkness itself into a weapon, using living light to tip the odds in its favor. The next moment, the jaws will do the rest. The instant a target comes close, the anglerfish's jaws swing open, revealing a mouth that borders on the impossible. Dr. Carlos Rivera, a comparative anatomist, demonstrates how the jaw bones are not fused like those of most fish, but instead held together by flexible ligaments and joints. This design allows the mouth to open wider than the fish's own body, stretching the skin and muscles into a cavernous trap. Needle-like teeth, angled inward, ensure that once prey enters, escape is nearly impossible. Inside, the stomach is no less extreme. When food is scarce, the anglerfish can go for months without eating, its metabolism slowing to a crawl. But when a meal finally arrives, the stomach expands more than twice its resting volume. Rivera points out that this elasticity is not just a quirk, it is a necessity. Prey in the abyss can be as large as the anglerfish itself, sometimes even larger. There are documented cases of anglerfish swallowing fish twice their own length, the outlines of their catch still visible through the distended skin. Digestion is a slow process, aided by powerful acids and enzymes that break down even the toughest flesh and bone. The liver, swollen with stored lipids, acts as an energy reserve, fueling the anglerfish through the long waits between meals. Every part of this feeding system is tuned for feast-or-famine living. In the deep sea, where hunting is a rare opportunity, the ability to consume and store massive amounts of food in a single event can mean the difference between life and death. This anatomical extremity is not just a curiosity, it is the price of survival in a world where the next meal is never guaranteed. In the world of anglerfish, survival has driven evolution to its most bizarre conclusion. Males, barely the size of a thumb, spend their short, solitary lives searching for a female, often thousands of times their own mass. When he finds her, the story takes a turn no other vertebrate can match. The male bites onto her skin and never lets go. Enzymes dissolve the boundary between their bodies, and over weeks his tissues fuse with hers. Blood vessels knit together. The male's organs wither away, eyes, gut, even his brain, until only testes remain, nourished by the female's bloodstream. He becomes a permanent appendage, living only to provide sperm on demand. This radical fusion, once dismissed as a myth, is made possible by a genetic quirk. Recent work by Dr. Hannah Lee and her team uncovered that some deep-sea anglerfish have lost the genes for MHC2, a key part of the immune system responsible for rejecting foreign tissue. Without it, the female's body tolerates the male as if he were part of herself. In other vertebrates, such a merger would trigger a violent immune response. Here, it is the foundation of their reproduction. Yet this adaptation comes at a cost. These fish lack the defenses most animals rely on, making them vulnerable to infection. Scientists debate how they survive at all. Despite decades of effort, direct observation of these behaviors is astonishingly rare. Maya Chen, an oceanographer who catalogs deep-sea footage, notes that in over 28,000 hours of ROV video, anglerfish like Oneirodes have appeared only 9 times. In 2023, a remote vehicle finally captured 4K footage of a female drifting with her living mate attached, a glimpse so rare it made headlines worldwide. Even now, each new sighting raises more questions than answers. Autonomous underwater vehicles are set to probe deeper, but for now, most of the anglerfish's private life remains hidden, stitched together from fragments and speculation. In these depths, the strangest truths are the hardest to see. Even now, over 1,000 anglerfish species remain hidden in the deep, many never seen alive by human eyes. As technology pushes exploration further, each discovery challenges what life can become under pressure. The ocean's darkness still holds secrets, and not all of them want to be found.